go. Okay, what's up? Happy Tuesday. So today we will try a couple of problems. I want to spend about like 1 hour and then that's it. It's pretty late right now, 10 p.m. So few things today. I want to do the daily challenge, and then I want to do dynamic programming, the second dynamic programming problem. So let's see if we can do this one right here. Set a timer and go. This is easy question, so let's see. Minimum bit flips to convert number. A bit flip of a number is x is choosing a bit in the binary representation of x and flipping it from either 0 to 1 and 1 to 0. For example, x equals 7. The binary representation is 1, 1, 1, and we may choose any bit, including any leading zeros not shown, and flip it. We can flip the first bit from the right to get 1, 1, 0, flip the second bit from the right to get 1, 0, 1, flip this, blah, 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 blah. Given to integer start and goal, return the minimum number of bit flip to return start and goal. Jeepers. So first things first, I need to know how to turn this into binary 2-bit. If I can't look it up, there was something that I used before, something like it's a JavaScript built-in function to convert a number into binary number. First things first, that's the thing. Okay. What is it? Hold on. Is it 2 fix? So I'll just say 4. That's equals to undefined 2 fixed. If it's not 2 fixed, then I would just Google it on JavaScript from num to toString. Okay, toString 2. Let me see. I forgot which function, but if it's toString and then we get 10, 10, and then I'll say start bits, and then go bits to go dot toString, and then we have start bits and go bits, and then see what happens here first. So we got this now. So answer should be 2, no? So goal that to string 2, goal bits is, why is it 1, 1, 1? Shoot. Wow, how do I know if it's like Where's the 0 here? Why is it not 0 1 1 1 1? Well, we need the binary representation, so it is that. But the 7 is not even 4 numbers. How do we? So we start from the n. The n. Flip 1, flip 2, and then. Oh my god. What if the length is not the equal length? Isn't it weird? How do I make it equal length? I want to give up already. Honestly. So minimum bit flips to convert number. We may choose any bit, including any leading zeros not shown, and flip it. Okay, we can flip. So leading zeros are not shown, and then we still need to be able to flip it. So what if the start is 1 1, and then goal is 1 0 0 1 1 0, like this? What's gonna happen then? My question right now, what if different length of bits? So what do we do? What do we do? I don't get it. Shit. Anyway, look at that. So if we start from like this, 11, and then when we hit 0, so what do you see from here? What I'm seeing is we're pushing all the numbers towards the end, and then if I don't have any numbers, just add 0 and then try to flip it. So what is the fastest way of doing that? If this bit is smaller than that bit, then we push in number or shift number. So that's not really performant per se. Can I hit the hint? XOR operation with its bits needs to flip XOR operation. I can't even loop like the end from the end to start. So how do I start? Goal is 7 and 0. But we want to make it that way. Oh lord. This is easy. What do I do? So if it's different length, find difference and add zeros. Leading zeros. That's the first thing, right? So let's see. What do I do? If start bits dot length less than go without length difference is equals to and then we want to let I equals 0 less than go without length. No. Less than equals to div I plus plus, and then here we want to just start bits dot unshift a leading 0. If this is a string, I just do it as well. Else, then I just do invalid left. What the heck? How do you how do you add a string plus? Oh shit, like that. Oh yay, okay, that works. So we have that. And then we do another for loop, right? For let I equals 0, I less than go without length now. I plus plus. So now we're checking. I want result, and then return result at the end. But here, actually, I want to start from the end. Goal is that or the same shit, no? Same shit. Front and the back is same thing. So if I want to hit like from here. Goal bits, this is the goal bits, right? If start bits of I is not equals to goal bits of I, I just want to rest plus plus. But if it's the same, just pass it. Okay, that's it. Output is 2, expected 3. Hold up. This is 100. But why do we have 2 leading? Oh. It's gonna be this is gonna be if the start bit is smaller, but this is goal bit is smaller, then goal bits. I'm gonna take this out, and I think that's it. Why is it not? If start bits is greater than let me see. Start bits is 11. It's less than goal bits that length. This. So difference bits 3 minus 2 is okay, like this. Like that. Oh, let's see. Of course, this is not this easy. Bet. Oh, okay. Alright. I'm dead last in the runtime. But I passed it though. Okay, hold on. Let's clean up a couple of things. Let's see. Man, I'm like dead last, bro. 5.8%. Oh, there you go. Well, not bad. Not bad at all. Time. Let's see. How much time? 16 minutes. Yeah. Okay. Yay. So far, we're keeping a hot streak right now. 2 of 2. 2 days in a row. Let's go. Off the daily challenge, right? So the thing about dynamic programming, I feel like it's using a lot of pointers. You're just adding the data, keep adding the data as you go into into the array. You just keep going. So we'll see about this one right now. We'll find out. I have 45 minutes to finish this one, and then call it the day. Call it a day. Let's see how long. I think this one is a little bit smaller. It's harder to see on the screen, so hopefully this is okay now. 790 Domino and Tromino tiling. You have 2 types of tile, a 2x1 domino shape or a Tromino shape. You may rotate the shapes. So this is Tromino tile. Given an integer n, return the number of ways to tile a 2x(n) board. Given an integer n, return the number of ways to tile a 2x(n) board. Since the answer may be very large, return it modulo. What the fuck? In a tiling, every square must be covered by a tile. 2 tilings are different if and only if there are 2 4-directional adjacent cells on the board such that exactly one of the tilings has both squares occupied by a tile. The book. So example 1, you have n of 3, meaning n of 3. So 2 times 3 is 6. Let's see. N equals to 3. So 2 times 3, so 6. And that's why we need... Wow. What the fuck? Wow. How do we do this? We have a domino and we have a tromino. It could be a combination of that too. Like if it's an 8, you could have like 1, 2, 3, 4. Okay, let's see. What do we know about domino and tromino? So could this be an odd number? Three times 2 is 6, 4, 5, 6, 7, 8, 9, 10, 11. So no, it's only gonna be even numbers. And then what do we know? For 6 we could do it this way. Wow, there's so many combinations, no? You put it top here, put it top left. This could be... Oh, it doesn't matter like how, but it just matters that you place it. You don't repeat the same placement. So right here, one is vertical on the left, this is vertical on the right, and this is all vertical. It could get very interesting if this is 6, right? Oh my goodness, this is like one of the worst question. What the heck? Let's just say we have 12. If we have 12, then oh geez. Okay, relax. So let's think about it this way. Let's just say n equals to 1. So 2 times 1 equals to 2. And there's only one way to put a 2, right? And n equals to 2. It's going to be 2 times 2 equals to 4. How many ways can you put a 4? With the domino, I'll need that. Makes sense? So let's see, if n equals to 3, then you get that. Answer is 5. So n equals 3 is the first one that we were able to use because that's a minimum 6. Okay, now we know if there is a 6 key right here, if we have a 6 and if we have a 2, because you can't use just one Tromino, you need to use 2 Tromino. This is the beginning of Tromino, and Domino starts at 1. So now that we know that, let's just say if we have 8. Okay. There is 3 ways of the domino to use that, and then 2 of the. So if we put it on the array, it's going to be if 0n, it's gonna be 0. 1n is gonna be 2, and then 4, and then 3 is 5, and then if n equals to 4, then 4 times 2 equals to 8. In 8, I know that if you have a 6, you have 2, and if you have 6, you have 5, and then add the what am I talking about? 6 and 2, right? 6 and 2. 6 is 5 and 2 is 4. So there's 9 ways of doing that. 1, 2, 3, 4. I feel like that's the way. So 9 is additional of the 2 numbers there. So using dynamic programming, but 2 plus 4 is not 6. And right here. And it's not guaranteed that I'm right with the 9. Two tilings are different if and only if there are 4 directionally adjacent cells to the board such that exactly one of the tilings has both squares occupied by a tile. What does that even mean, bro? What does that even mean? Because we know it couldn't be odd numbers, so they couldn't be joined together other than, yeah. If it's 8, it's gonna be 1, 2, 3, 4, 5. Shit. Every square must be covered by a tile. Every square must be covered by a tile. The tiles are different enough and different. So the problem that I'm facing right now, I don't know how to test out because it's pretty big. So if you want to just try it out, n equals to 4, so that's gonna be 1. And it shapes. So this is domino. Let me see. Can I make the domino? So this is domino. 5, 8, right? 1, 2. Okay, actually this is this domino tile, like that. Or like, can I spin it? Can I rotate? Can't rotate. Can't rotate that shit. Anyway, 1, 2, 3, 4. Right? Yeah. Oh my god. Okay, so what? Let's just say this is 9, 14, 23. No, but I don't think so, because this could get very large. Very, very fast. I don't know the math just now. I have no idea about the math, that's why. This is 4 or 5. How do I find out? How can I find out? One, two, three. Is that 5? N equals 1 is 1. Huh? N equals 1, how is it 1? So this is 2 tile and that's 3 tile, is that it? Yeah. Yeah, 2 types of tile, a 2 by 1 domino shape and a Tromino shape. So just that's kind of 2 or what? Oh my god, what the fuck? Yeah, this is kind of 6. Alright. So a 2 tile. That's equals to 1 actually. So that's gonna be 1. 4 tile. Well, that's equals to what? If it's a 4 tile, you could do 1 or 2 ways. So 2 ways instead of 4. I still don't see. Is this one right here? Anyway, if it's 1, doesn't make sense. So how do we math? Becomes 5. Wow, so tough. So tough. What do we do then? Eight is how many ways ways that we can show the 6 and how many ways can we show the 2? 6, if it's 8, I can show 6 is 2, and the 2 can do 1, 4, 5. So this is 7. So imagine if this is the way. Imagine if this is actually the way how to do it. This is index of 0, 1, 2, 3, 4, 5, and 6, and equals to what? This is n equals to 0 and 0. 1 is 1, 2 is 2, and 3 is the last 2 number. 4 is the last 2 number. So what do we do? Let result equals to 0, 4, let I equals 0, I less than equals to n, I plus plus, and then we do let's start cloner equals to 0, let second, where is first pointer and second pointer equals to 1. First plus 0. How do we start this? We can start by say I equals 1. If I equals 1, first become I don't know. Okay, I give up. I hate those solution. Yeah, dynamic programming, I'm not having fun. Oh my god, I really am not having fun with dynamic programming. Okay, I'm not going to solve this. I'm going to find a way someone can explain to me what is dynamic programming.
Hey CS Dojo, it's YK here. So in this video, I'm going to talk about what dynamic programming is and how to use it. And as I explain how it works, I'm going to assume that you're already familiar with recursion. So what is dynamic programming exactly? It's actually fairly simple, even though it might sound difficult. It's basically a way of making your algorithm more efficient by storing some of the intermediate results. And it works really well when your algorithm has a lot of repetitive computations, so that you don't have to repeat those computations over and over again. And I'm going to give you a concrete example of how it works with Fibonacci sequence. So just in case you're not familiar with it, Fibonacci sequence is a sequence of numbers that starts with two ones at the beginning, and each number after that is computed by adding up the two previous numbers. So the third Fibonacci number is 2 because 1 plus 1 equals 2, and then the fourth Fibonacci number is 3 because 1 plus 2 equals 3, and so on, and this sequence keeps on going forever. So let's say we're trying to solve the problem of finding the nth Fibonacci number, or writing a function called fib of n, which takes a positive integer n and finds and returns the nth Fibonacci number. So if the given n is 3, we want to be able to find and return the third Fibonacci number, which is 2. And if the given n is 5, we want to be able to return the fifth Fibonacci number, which is 5. Let's see how we can solve this problem using dynamic programming. So if you want to solve a problem using dynamic programming, there are typically 3 steps you can take. The first step is to come up with a recursive solution to your problem. And then in your recursive solution, if you notice that there are a lot of repeated computations, you can then store some of the intermediate results so that you don't have to repeat those computations. This process is also called memoization or memoize, and this is not to be confused with memorize. And I've made that mistake before too. And then the third step, if you don't like using recursion anymore, is to come up with something called a bottom-up approach. So let's first see what a recursive solution might look like for this particular problem. So as I said earlier, we're going to write a function called fib of n, which takes n a positive integer and returns the nth Fibonacci number. And if n is equal to 1 or 2, we know that the first and the second Fibonacci numbers are 1. We're going to return 1. But instead of returning it right away, we're going to store it in
Hello friends, today I'm going to solve Leetcode problem number 790, Domino and Tromino tiling. So in this problem we are given two types of tiles. One is a 2:1 domino shape, another is a Tromino shape. So basically these are the two tiles, the shape of the two tiles. And what we need to do is we need to fill a board of 2 by n and return the number of ways in which we could fill or the number of ways in which we could tile the board of size 2 by n. And we are going to use this modulo operator since the number could be a very large number. Now we are given here an example on how we could tile this board. So one way is to tile one straight and then 2 horizontal, or all of 3 vertical and 2 horizontal, 1 vertical, or the Tromino tile. And the Tromino tile can also be arranged in like different ways by rotating them. So now let's see how we could solve this problem. So what if we have to the number of tile, the value of n is equals to 1. That means we only have a board of 2 by 1, right? So how can we fill this? Well, we can fill that by only using a domino, right? A vertical placement of the domino. What about if the number of the value of n is equals to 2? In that case, we'll have a square board with two rows and 2 columns. So how can we fill this? Well, basically we can fill the first one by one vertical line, the second one by another vertical line, right? But we could also fill this by 2 horizontal dominoes. So we could fill it by 2 vertical dominoes and 2 horizontal dominoes. What about 3? In that case, what we could do is we could fill with 3 vertical dominoes, or we could fill it with 2 horizontal domino and 1 vertical domino, or we could also fill it with 1 vertical domino, 2 horizontal domino. But we should not forget that we also have Tromino as well, right? So we can also fill it with a Tromino. How? Let me just show you by drawing the board. So this is a 3 by 3 board. So how can we fit our Tromino in this? If I take a Tromino, so this would be one Tromino, then the other Tromino that I can fit in is in this way, right? So this would be another Tromino. So what I have is these 2 Trominos. I can also fill the Tromino in another way as well. So how can I fill the Tromino? Again, by rotating it. So when I rotate the Tromino, the next way I can fit in is in this way, right? So by rotating them, I can fit in this way. So that would form a different value of n is equals to 3. What are we doing? We are to the value of 2. I'm gonna add 2 horizontal. So to the value of 1, what I rotate this and then fit a domino again to that one. So that is what I'm getting from 1 and 3, right? From 3, I'm adding the dominoes with a Tromino and a vertical line, and I rotate these 2 Trominos, and then I add again a domino to it, right? And for 1, what I did, I actually shifted these Trominos and then added a domino to the beginning. Now let's see another way. So another way is to use so I'm gonna fill this with this Tromino here and then this Tromino here. Now what do we have? I have a gap with two cells, right? So how can I fill this? I can fill this with a Domino, right? Similarly, I can do this by rotating this Tromino. So it would be something like this, and then I'll have a gap which could be filled with a Domino. So that would again form two cases, right? Two different cases. So what's happening is, let's see now. What's happening is, to find the value for n, I need n minus 1 value for n minus 1 plus value for n minus 2, because I'm adding n minus 1 plus n minus 2. And what about 1? From 1 I'm getting two different values, right? So there are two different ways again here. So n minus 3, and then again from 0 as well, it's the same thing, right? Two I get two different ways, so I can add 2 times n minus 4. So it will keep on repeating for any values of n. So now simplifying this, what would we get? We will get is 2 times n minus 1 plus n minus 3. So upon simplification, we'll get this formula, and we are going to use this formula to find the value of n. So for that, we are going to use dynamic programming method. So now let's try to solve this problem. So so what do we need? We need to define the values for 1, 2, and 3, because that is what will be our base cases. And then again, we need a dynamic programming, right? dp map. So this is map, and then I set the values for 1, which is equals to 1, dp of 2, which is equals to 2, and dp of 3, which is equals to 5, right? From this solution, we know that it is equals to 5. From I equals to 4, I is less than equals to n, and I plus plus. Why n? Because we are starting from dp index 0, so that is why we need to reach until n, because that is where dp of n will hold our final value. So now dp of I will be equals to 2 times dp of n minus 1 plus dp of n minus 2, n minus 3. And then what do? Is we return the dp of n. Now let's see one more thing here. So what do we have here is we need to return modulo, right? So let's just define a constant variable, and every time we find the value, we are just gonna take the modulus and then finally return it. So let's run our code and see if it's all right. Okay, something is wrong here. It's not a number. Okay, we are actually taking the value I minus 1, because for index I, we need I minus 1 and I minus 3, right? Let's submit it now. Cool. So the time complexity, and then finally return it. So let's run our code and see if it's all right. Okay, something is wrong here. It's not a number. Okay, we are actually taking the value I minus 1, because for index I, we need I minus 1 and I minus 3, right? Let's submit it now. Cool. So the time complexity is O of n, and the space complexity is also O of n.
The fuck? So what is this number? Is this even like matter here? So you could just do this. Like this number don't even matter. Wrong answer. Wrong answer. Guess it has to be 2. Where did I get 1 from? Should it be 2? So why is it I minus 1? When we're at 4. What comes from 4. I is 4. I minus 1 is, because this, you gotta multiply that, and then dpi minus 3. Minus 3 is what? 4 minus 3 equals to 1. Still don't get, like, why is it not that one? Maybe she was explaining it.
Like this, and then I'll have a gap which could be filled with a domino. So that would again form two cases, right? Two different cases. So what's happening is, let's see now. What's happening is, to find the value for n, I need n minus 1 value for n minus 1 plus value for n minus 2, because I'm adding n minus 1 plus n minus 2. And what about 1? From 1 I'm getting two different values, right? So there are two different ways again here. So n minus 3, and then again from 0 as well, it's the same thing, right? I get two different ways. So I again add 2 times n minus 4. So it will keep on repeating for any values of n. So now simplifying this, what would we get? We will get is 2 times n minus 1 plus n minus 3. So upon simplification, we'll get this formula, and we are going to use this formula to find the value of n. So for that, we are going to use dynamic programming.
The fuck, yeah. I don't like the explanation. Like, what is that?
Adding n minus 1 plus n minus 2. And what about 1? From 1 I'm getting two different values, right? So there are two different ways again here. So n minus 3, and then again from 0 as well, it's the same thing, right? I get two different ways. So I again add 2 times n minus 4.
So from here, what would you get here?
Will keep on repeating for any values of n. So now simplifying this, what would we get? We will get is 2 times n minus 1 plus.
Why is it 2 times n minus 1? You take n minus 1.
N minus 3. So upon simplification, we'll get this formula.
Upon simplification, you get this formula from where? See, but okay, fine, whatever. So the thing about this is the formula. I don't get the formula. That was a rough one. So yeah, DP is still my weakness up until now. Have to practice some more, but that's it for today. And yeah, that was a rough one. We'll get back at it again tomorrow. That's it.